everyone, we're going to find the solution set for each rational inequality. This is part 4, so they're getting a little harder. And the first one we're going to do is this one. These are strict inequalities. They're called strict inequalities because they don't have an equal sign. If they're non-strict, they would have an equal sign. So the first one we're going to do is this one. I'm going to go ahead and move... subtract the 2 over 3x minus 9 and set this to 0. So we want this to be negative. This just means our inequality. We want to know on the graph, where is y negative? Where is y negative? Okay, so the first thing we have to do is get our common denominator, which is going to be x minus 2 times 3x minus 9. And what you can do is just do the rainbow cross these. So you're going to get 3x minus 9 minus 2 times x minus 2 is less than 0. You simplify all that out and you're going to get x minus 5 over your common denominator. Now, to find where the graph is negative, where y is negative, we're going to get our zeros. So set our numerator to 0, and that gives us 5. So there's a 0. And then we have to find where f is undefined. And you just look at the denominator, and f is undefined at x equals 2 and x equals 3. Because you plug those in, it'll make the denominator 0. So these are our 3 points, 5, 2, and 3. Now if I do a little number line here, I'm going to put the smallest number first. We have 2, then 3, this would be x, and then 5. So our first interval is going to go from negative infinity to 2. Our second interval is from 2 to 3. Our third interval is from 3 to 5. And our last interval is 5 to infinity. Alright. Now I'm going to pick numbers in these intervals. And the ones I chose were 0, 2.5, 4, and I picked 6. And I plug it into my function, and I'll write it out. It's 1 over x minus 2 over 3x minus 9. And again, we want this whole thing to be negative. So I plug in my numbers, and I'm going to get negative. I'll do that. Negative 5 over 18. 10 over 3. Negative 1 over 6. And 1 over 36. Okay, so here is negative. That's what we want. So we want this interval. This number is negative, and so we want that one. These two are positive, but we just want negative. So our solution set, therefore, is x is less than 2, or this one, x is in between 3 and 5. This is a strict inequality, so we don't have any equals there. And the next one's very similar. I'm going to go ahead and move the right side over by subtracting it. And this one we want positive. So my common denominator is x plus 1 times x minus 3. You just kind of cross these two. Students call those, say, the rainbow. And when you simplify that, you're going to get 2x plus 14 over x minus x minus 3 and x plus 1. All right. Now, set your numerator to 0 to get your 0. Or you can just tell by looking, that's going to be negative 7. So we have a x equals negative 7. And where is f undefined? And it's undefined at 3 and negative 1. That would be your vertical asymptotes. Okay? This would be your x-intercepts. Okay, so I'm going to do a number line here. Let's see. And we have negative 7, negative 1, and 3. So our interval is going to go negative infinity to negative 7. That's this side. And then we're going to go from negative 7 to negative 1. That's this piece. Then negative 1 to 3. That's that interval piece. And 3 to infinity. All right. And I choose numbers. I chose negative 8, negative 2, 0, and 4. And I plug it in my function. Again, your function was f of x equals 5 over x minus 3 over x plus 1. Now, when I plug my x values in, I get negative 2 over 77, 2, negative 14 over 3, and 22 over 5. Well, we want positive values, and that's a strict inequality. So our positives are right here. Positive, positive. All right, so there and there, these two happen to be negative. So my solution set is x such that negative 7 is less than x, is less than negative 1, or x is greater than 3. And that's all. Thank you. Have a nice day. Bye-bye.